So today I'm going to be talking about U-substitution. Well, its basic definition, I suppose, is where G is a function whose range is an interval I, and f is a function that is continuous on I. And then if G is differentiable on its domain and f is an antiderivative of f on I, then the integral of f g of x g prime of x dx is equivalent to the antiderivative of g of x plus c. And when letting u equal gx, gives du equal g prime of x, and then the integral of f u du is equal to f u plus c g x is equal to g of x. So yeah, you just substituted the gx with u. You could see. And then the du was g prime of x. So you substituted both. This here. So anyway, let me erase this. So let me do an example now. So let's do I equal or equivalent to the integral of 1 to 5, and this is and a definite problem. So we're 2x minus 7 all over the square root of 7x minus x squared dx. So because we don't know its antiderivative right off the bat, we have to employ U-substitution. So first, you define your U is equal. It's basically what's like under like a square root or with a trig function, or like what's ugly, in other words. Something that's being raised to a power. So in this case, it would be 7x minus x squared, and then you define du, which would be the derivative of u, which in this case would be 7 minus 2, because you just bring it to the front and then subtract the exponent by 1, x dx, and then you define dx by just simply solving for it, in this case it's du all over 7 minus 2x. And you could solve for x. I don't think we need it in this case. So then you just substitute it back into the integral. So 2x minus 7 all over the square root of u now times dx, which is du all over 7 minus 2x. And you could simplify, so this would go away and this would go away. But there needs to be a negative. Let's keep that in mind. So 5 to 1, so negative 1 times 1 all over the square root of u. So now we could simplify this more, like bring this up to the top, which would make it u to the negative 1/2. And then so now you need to take its antiderivative, in which you would add 1, so it would turn into positive 1/2. So positive u to the 1/2, and then this would be, you could do reciprocal, which would be 2. Or you could do an equation like 1/2 x is equal to 1. So what would x have to be? Anyway, and then you just add the negative. So now anyway, so now you need to plug in these values in for u. So let's do it up here. U is equal to 7 times 5 minus 5 squared. This is 35 minus 5 squared is 25, which is 10. And then you plug in the other one, which is 1 minus 1 squared, which is 7, minus 1, which is 6. So then it's 6, like 10, and then you would simply just do the fundamental theorem of calculus where you would just plug in b and then subtract it with when you plug in a, like this. And that should get you your answer. For indefinite integrals, there would never be an interval, like a range, and you'd need to have like plus c at the end. Limit. So like the fundamental theorem of calculus is basically where you do so like -2, so you do the antiderivative and then do b, plug in b minus a, so -2. I'd plug it in for u, right? And so it'd be b 10 minus a when I plug it in. Can you please? And what I'd end up getting was -2 square root of 10 minus plus, because negative is a negative, 2 square root of 6. So let me just erase this. And just really quickly, remember all the rules. The second fundamental theorem of calculus is basically where you would take the top b and then you would plug that into the x value and then you would take its derivative, like of the top one, but you just plugged in. And if there's something like more like another more than one in the as for a, then you would subtract that and do the same process, like subtract that from what you just did. And note that the mean value theorem kind of goes with the average value theorem, but it's basically where it's like 1 over b minus a times the fundamental. Yeah. The integral. And yeah, you just might need to employ other rules. So that's it.